determinant of a matrix is kind of like a property of it. Okay, it's a number, and depending on what that number is, it tells us something about that matrix. If that number is anything other than 0, it tells us that that matrix is what's called invertible. We'll talk about inverses of matrices in just a little bit. But the determinant is an easy thing to find, especially if it's small. But a determinant can only, spell only, O-N-L-Y, be found for square matrices. What do we think square matrices would mean? Victoria? Rows and columns are the same. So it could be a 2 by 2, could be a 3 by 3, could be a 65 by 65. That's square. Means you have the same number of rows and columns. An n by n is how you'll see that a lot of times when you read a description. An n by n matrix, meaning it has the same number of rows as it does columns. A determinant can be found for that. We're just getting started, Ted. So determinants can be found for square matrices only. If it's not square, you can't find the determinant for it. Okay, that just can't be done. All right. Now, ways that they tell us to do the determinant. There are different notation for that. Sometimes it's straightforward, and they use the abbreviation DET, and then they'll put the matrix in a parenthesis. And that says find the determinant of that 2 by 2 matrix. That's what that says. Or they may use this notation. They put the matrix in there, and instead of drawing square brackets around it, they put what looks like absolute value marks on it. Okay, just straight up and down bars. No bracket, just straight up and down bars. That also means find the determinant. Those notations. So if you see either of those, that's find the determinant of that matrix. 2 by 2 matrices are really easy to do by hand. Anything bigger than that really expands how many operations you've got to do to find that. So 2 by 2s are the only ones I really ever do by hand anymore. Used to have to do all of them by hand when I took, some of the college classes. So if you're going to be an engineer, get ready. You'll have some fun doing these by hand without a calculator eventually. But I'll let your linear algebra teacher in college teach you how to do that. I'm going to teach you 2 by 2 by hand because it's so quick to do. 2 by 2s are easy to do by hand because all you do is you multiply the diagonals. A times B minus B times C. And that number that you're going to get is the determinant of that 2 by 2 matrix. Okay. Multiply the diagonals. Always start in the top left, and that goes first. Okay. Top left is always going to go first. A times B, then B times C. Okay. So easy to do by hand for 2 by 2s. I'll show you how to do it with calculator as well, but easy stuff. All right, so let's get a 2 by 2 matrix. Let's say 5, 4, -3, 7. And I'm using the bar note, the absolute value bar notation there. I could also write DET and then put the brackets. It's the same thing, okay? But I'm going to find the determinant of that 2 by 2 matrix. It's got to be square. This one is. It's 2 by 2. And I just start with the top left and do that diagonal. 5 times 7. So I'm going to write it out here so we know where we're coming from. Minus 4 times -3. It's always a minus sign in the middle there for 2 by 2s. Okay. And then you just do the math. 35 ends up being plus 12 because it's -4 times -3, which is 47. The determinant is 47. Woo! Great. We know that. All that tells us really is that we could find an inverse of this, and I'm going to show you how to do that later. Okay. Okay. That's all for algebra 2. That's all that tells us. for you go into linear algebra and things for engineering school. There's some other things that tells you, but it doesn't matter for algebra 2. Okay, finding that. Now, how can you do that with the calculator? Well, get out the old trusty graphing calculator, go to the matrix menu, edit, put in a 2x2 matrix that has those numbers in it: 5, 4, -3, 7. Make sure I put those numbers in right. Yeah, those are the right numbers. Okay. Then I'm going to go to the regular calculator screen, so second mode to get there. Then I go to second, and then the matrix menu again. I'm going to do some math with that matrix this time, so I want to go over to the math menu. That very first option is DET. That's a determinant. Okay, that's what that means. So I'm going to select that option number 1, and then I'm going to tell it what to take the determinant of. Second matrix. I put it in matrix A. And you don't have to close the parentheses, but I'm going to. And there I get the same 47 that I got by doing it by hand. Now, it took me several button pushes and a lot of just stuff I didn't have to do. For 2x2s, I do those by hands because it's faster than doing that. Anything bigger than that is not faster because there's a 3x3, just one row and one column bigger, takes, I think I counted up, over 20 operations to do, where this one took 3. 2x2s take 3, 3x3s take around 20, 4x4s go like it's closer to 60 operations that you've got to do. It gets big quick when you try to do it by hand. I don't expect you to do anything bigger than a 2x2 by hand. Okay, so if we did a 3x3, let's say we had 6, 5, 0, -1, 8, 11, 3, -4, and 0 again. I'm going to put that in the calculator and get it to crank out the determinant of that. I'm going to show you how to do it by hand too, since we got some folks that don't have a graphing calculator. If I'm going to do it by hand, this is one method for doing that. One method is to take the first 2 columns and recopy them. And then you start doing multiplications with those diagonals. So I would take those first 3 diagonals there that have 3 numbers in them, and then I'd multiply all those together. 6 times 8 times 0 plus 5 times 11 times 3 plus 0 times -1 times -4. Okay, I'd put all that together. And then I'd go the other direction, and I would subtract off the other diagonals. Okay, so I'd have to multiply 3 times 8 times 0 plus -4 times 11 times 6. Yeah, the graphing calculator is your friend, no doubt. It's looking better all the time. $15 is not bad to rent one of those. Okay. All right. Now, all that stuff, look how many operations that is. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then there's 11 again. That's 22. And then 23, a subtraction of that after you get done with that. 23 operations to do a 3x3. This one works out nice because you got some zeros in there. But you don't always have zeros. Right? So that makes it tougher. Okay. So that's how you would do it by hand, and then you do that math and work it out. That's we live in the year 2018, and they created this wonderful thing, a graphing calculator, several years ago. You guys got the TI-84s. Some of you got the color screen ones. They're nice and everything. When I was in school here, Miss Campbell had TI-82s back then, and they did a lot of stuff, but it took them a long time to do. They're real slow. They didn't have much memory and stuff, so made it tough. Let's get that number 650. 0. What's the second row? Negative. And then, okay. All right, so we got that 3 by 3, second quit. I've already put in DET of A up there. If I want to reuse that, because I put mine back in A again, I can just press up and grab that one. And now it says, oh, A is a different matrix now. And crank out that answer, 429. And all of that to tell us that we can get the inverse of that matrix. That's what that tells us in Algebra 2. Okay, 5 times 11 is 55 times 3, be 150 plus 15, 165, and then that's negative 44 times 6, be negative 240 plus 24, negative 266. And whatever that other number was, so we're subtracting that, and that adds to be 429. 23 operations as opposed to, what, 11 button pushes?
Well, hang on a second, I gotta ask you. So I just put all that in on the calculator. How do you get 4.9?
The matrix or this?
That whole function.
And I may have miswritten something here. So that's. She get you? Okay, awesome. Thanks, Molly, for taking care of Gavin for me. Negative 4 times 7 times. Is that 6? I'll see if I'm right. I don't know. Yeah, same number. If you got one of your rows or one of your columns swapped around, you could get the same number but a different sign, a positive or a negative there, depending on that. So. Yes. All right, so determinant. 2 by 2s, easy to do by hand. Anything bigger than that, not so much. Okay, so if you haven't got a graphing calculator yet, I suggest you find one for the next couple of days. All right. Now, there is another geometry application of the determinants, but I'm not overly concerned with that with you guys. If this was a geometry class, I would do that, but it's not. So let's talk about the next thing, which is row operations. Row operations. This is a fun thing. I said that with a laugh. I tried not to laugh, I promise. Row operations are easy, but you got to be careful. Just like anything else, it's an operation. So there's a chance that you misadd, or you forget a negative sign, or you just do something dumb, okay? Or you use the wrong row, okay? When we're dealing with row operations, I think the best thing to do is just do an example. Let's say we had a matrix. Doesn't really matter what size it is. We're doing row operations. You can do row operations on any size matrix. So I'm going to use a 2 by 3 here to start off with. So let's say we had 2, negative 4, and 8, and then 10, 6, and 1. Make it easy on us. Okay, that's our matrix. We get that matrix going on, and then they say, okay, do this specific row operation. So I'm going to tell you what a row operation to do. The practice you're going to do with Khan Academy, it's going to tell you what row operation to do. And what it's going to do, it's going to say, okay, perform this row operation. Let's say -5 times row 1 plus row 2, and then they put this arrow, and that tells you which row to change. Okay? They're saying change row 1. Okay? That's the row operation we're going to do. That says take -5, multiply it times row 1, and then add it to row 2. But then take that answer and replace row 1 with it. That's what it means to do. Sounds super complicated, but the math part's easy. Okay? So to do that, which row is not changing? Row 2. So when I go to write my answer, I'm going to just copy row 2 to start off with. 10, 6, 1. It's not changing because the arrow said change row 1 only. It's never going to say change 2 different rows at the same time. You're only going to do one at a time. Okay? So we're going to just do this math. We're going to say -5 times row 1. So what's -5 times 2? -10 plus row 2. So -10 plus +10 is 0. So we put a 0 right there. Okay? It sounds like it's rocket science. It leads to rocket science, but it ain't rocket science. Okay? -5 times -4 plus 6, 26 goes right there. -5 times 8 plus 1, -39. There's easy ways to make mistakes there. You've got to be careful with that. Okay? Row operations, you don't have to have a graphing calculator for. I don't recommend doing them with a graphing calculator because it takes too much time when you could just do it. And this is not hard math. It's not, I'm going to give you hard math. So this matrix, that's your answer. Okay?
Just in time for the answer.
Yeah, just in time for the answer, Coach. We're doing matrix row operations today. Fun.
I know exactly how to do that.
He does. He's done it. That's part of being an assistant principal, is you have to do matrix operations a lot in the office. Let's do 2, -3, 6, 10. 1, 5, 11, -2, and 4, 7. What's your favorite number, Coach?
I'm thinking that's looking a little bit like Sudoku more.
It is. It's a lot like that.
Okay.
What's your favorite number? You gotta help me.
10, of course.
10. Okay.
10's already up there.
Well, that's okay. We can use it again.
Okay.
All right, we'll use 10 there, and we'll use -10 here to cancel it out. Okay. What size is that matrix, folks? 3 rows, 4 columns. Does it matter if I'm going to do row operations, what size it is? No. What matters on size? When we're finding the determinant, what's it have to be to find the determinant? Square. Okay, so this is not square, obviously. So row operations, let's say we took negative row 1 plus row 3, changing row 3. Okay. Negative row 1 plus row 3, changing row 3. All right. We go to write our answer. What's not changing? Row 1 and 2. So what are we going to do with those? Keep them the same. Just copy them down. Making copies. Know that one? Rob Schneider. You remember that?
That's a good class.
They're way smarter than
They are smart. I haven't graded the quizzes yet. All right. So row 1 and 2, nothing's changed. Row 3 is the one that's changing because the row operation told me that's the one that's changing. How's it changing? All right, so we're adding a negative row 1 to it. So we go to row 1, that becomes a what? Plus row 3. So that ends up being +2 right there. Pow. Okay. Negative row 1, the -3 becomes +7. Coach Coughlin's favorite number. Negative row 1 plus 10. Negative 4, positive 4. I heard both. Positive 4. Okay. Negative row 1. Negative 10. Negative 10 is negative 20. There is our solution matrix. That's the answer. Row operations. Okay, that's okay. You can interrupt. That's what I want to do. You didn't copy everything I did. I'll get you a copy of it in just a second, okay? Because it'll take a long time to go back through. All right, so row operations. Now, we got 10 minutes left. I can do this. All right. Let's talk about solving systems. You guys are going to hate me when you see this. Because the reason you're going to hate me is because it's so easy to do this way compared to what we did on the first test. Okay? Yes. Because it's related to matrices. Solving systems. Systems of equations can be written as what's called augmented matrices. That's just fancy words for they've got the numbers in it and no letters. That's what that means. Okay? So, for example, let's take a system. I don't know what letter we're on. D, E. Example E. Solve the system. All right. If you're going to solve this system, let's say we have 3x plus y equals 16. And we had 2x minus 3y equals negative 4. There's our system of equations. Two linear equations. And, last week we had to do either elimination or substitution to solve that. Or we could graph them and get where they cross. That was wonderful and fun. And I enjoy doing that. But I want to show you how to do this with a matrix. So what we're going to do is we're going to take this matrix and we're going to put it into or take this system and put it into an augmented matrix. The way an augmented matrix works is you take your x's form the first column, your y's form the second column, and your answers form the third column. Okay? So we have 3, 2, 1, negative 3, 16, negative 4. We've taken this system. It's got to be in order. Your x's and your y's got to be on one side, numbers on the other. It's got to be in that standard form, like you were going to do elimination. You've got to be able to put the equation there. Then you throw it into this matrix. And I'm going to show you with the graphing calculator how you can get it to do, it does sometimes, hundreds of row operations to get it to work. I'm not going to make you do row operations by hand. Okay? That could take a while, depending on the system that you got. Okay? This one wouldn't take very long because you can do it kind of like elimination. It's really easy to do. But with this, what you can do is you take your calculator and you can get this matrix into what's called reduced row echelon form. I didn't make it up, I promise. If I would have, I'd have named it something like laser form or something cooler than reduced row echelon form. Or simpler, easier for a country guy to spell. Okay? Now, what that means, reduced row echelon form, or there's this guy, Gauss was his name, G-U-A-S-S, and Jordan, not Michael Jordan, but some other Jordan guy. They had they're credited with coming to this, the reduced row echelon form. It was Gauss-Jordan row reduction is what they did. They did row operations on this matrix until they got it into this form. 1, 0, and then a number. And then 0, 1, and then a number. Okay? a diagonal of 1s right there. What that told them once they got there was that x, this first, remember the first column is x's, right? So this says 1x, no y's, is equal to something. The answer. This one says no x's and 1y is equal to something. The answer. Okay, that's what they did. They did all these row operations, and they had done enough of them that they got credit for doing that. I don't know how many that was. I'm gonna try to see if I can get you guys to do the same number so y'all get credit for it, right? No. We're not gonna have to do the row operations by hand. I want to show you with the graphic calculator that you can get it to go straight to that from that matrix. So what we want to do is take that matrix and put it into your calculator. Second matrix, go over to edit. What size is that matrix we have? 2 by 3. Okay, 3, 1, 16, 2, -3, -4. Make sure I copied that right. 2, 3, -4, 2, -3, -4, 3, 1, 16. 3, 1, 16, 2, -3, -4. Good. Okay, so 2 by 3 matrix. All right, now here's where I got to do some math with that matrix. So I'm going to hit the matrix menu again. I'm going to go over to math. I'm looking for an abbreviation for reduced row echelon form. I'm going to start at the bottom. And now we're here. All right. RREF, reduced row echelon form. Right? That's an abbreviation for that. All the first letters. Reduced row echelon form. I'm going to pick that. And then I'm going to tell it what to do that to. Some are still trying to get. I started at the bottom now here. So 1, 0, 4, 0, 1, 4. That tells us that the solution to this matrix and that system of equations is the ordered pair what? 4, 4. 1, 0, 4. 0, 1, 4. The answer is the ordered pair 4, 4. How awesome is that? Now, could you solve it by substitution or elimination? Yes. Will you get the same answer? Yes. Okay? So if you don't have a graphing calculator and you don't plan on getting one, that's fine. You're just going to have to do this the long way. Okay? All right. Let's look at another one. Let's say we had this system, 5x minus 3. Got time for one more today. And we'll finish this up tomorrow. This one would be really easy to do with elimination, but I'm going to do it with the augmented matrix. What would our matrix be for this one? 5, -3, -3, 2, 6, 0. So we need to put that matrix into our calculator. Edit. 2 by 3 again. 5, -3, -3, 2, 6, 0. Quit. Second matrix. Go over to math. Find RREF. It's down at the bottom. Tell it what matrix to use that on. I put it in A. Crank it out. Oh, it got me decimals. Mr. Isbell don't like decimals. How do we change something from decimals to fractions in the calculator? Math, enter, enter. Bam. Now, what's the x value? -1/2. So we get the reduced row echelon form is 1, 0, -1/2, 0, 1, 1/6. The ordered pair, which is the way we write answers to systems, right? -1/2, +1/6. Now, could you have found that by elimination? Yes. Would that be easy to find by graphing? Absolutely not. It's hard to estimate where 1/6 is. -1/2, yeah, we can probably get pretty close to that. But 1/6, I can't eyeball on a graph the difference between 1/6 and 1/7. There's not much difference there, when you draw a dot. So tough to do, okay? So we're going to finish this up tomorrow. We'll get to bigger systems and just run through that real quick. And then we'll get some practice in tomorrow. We'll also see what infinitely many solutions and no solutions look like with matrices, okay? So